All right, hey everyone. We are going to do Unit 2, Test 3 remediation. So this is what your remediation paper should look like. We're going to go question by question and figure out what our answers should be. All right, for the first one, find a coordinate pair for a point on the graph. What I would do if I was a ninth grade student is I would plug in each one of these into x's and y's, because if you remember, a coordinate pair is x comma y. So let's try this first one. My x is 0, 4 comma 0, plus 2 comma negative 1 is equal to 2. Well, 4 or 0 times anything is going to be 0. Negative 2 is equal to 2. And negative 2 is equal to 2. So that's not a good answer choice. So, but it's close. I just need that positive answer. I need something like D. All right, something like D. Let's try that one. 4 times 0 plus 2 times 1 is equal to 2. 4 times 0 is just 0. 2 times 1 is 2. Is 2 equal to 2? Yes, ma'am, it is. The next one, we are eliminating, and the first thing I need to check to see if my equations are in standard form. Are my x's in a line, y's in a line, numbers in a line? And they are. Can I eliminate anything automatically? And I can. I can eliminate these x's. Now, from this point on, I'm just creating one equation. 5x plus 2x is 7x is equal to 7. Now, divide by 7 on both sides, x is equal to 1. Now, if you look at our answer choices, both of these are the same, which means that C and D are not good ones, meaning I've got to plug in x into one of the equations to figure out what y is. And I would do the bottom equation because the bottom equation has a positive y. 5 times 1 plus y is equal to 3. 5 plus y is equal to 3. Y is equal to negative 2. You subtract 5. 3 minus 5 is negative 2, meaning A is my correct answer. All right, number 3, you need to check to see where they both have the same intersection, the same points here. 3 comma 4, 3 comma 4, meaning 3 comma 4 is my answer choice. All right, Mr. Brown bought 7 tickets to a puppet show and he spent $43. He has a combination of child tickets and adult tickets. So I'm going to have C for child, A for adults. Child tickets are $4. Adult tickets are $9. Meaning I need an equation just full of money. All right, just full of money. 4C plus 9A is equal to 43. Now, whatever one does not have that, I'm eliminating. Not that one, not that one. Now, just because these two are written in 2 different forms, remember, commutative property tells us that no matter what the order is for addition, it doesn't matter. All right, it doesn't matter. Now, he bought a total of 7 tickets, meaning he could have 2 different options. He could have a child ticket, an adult ticket, and he bought 7 total. Now, the only option that goes with that is B. All right, is B. Now, this next one is pretty heavy duty. All right, it's pretty heavy duty. So, first thing we've got to do is put all of our equations into slope-intercept form. Slope-intercept, you've heard since 8th grade. Y is equal to mx plus b. Isolating the y, getting the y by itself. So this very first one, minus 5x minus 5x. 2y, whatever that sign is, negative 5x minus 4. Divide each of my terms by 2. So y is less than negative 5 over 2x. Now, a negative divided by a positive is a negative. This next one I'm going to do in purple. I'm only moving the 2x over. Minus 2x minus 2x. So y, whatever that sign is, negative 2x plus 2. So here, you've got a couple of different things you need to check. All right, and I'm going to write them down over this way. So I'm going to check my y-intercepts. I'm going to check my slopes. I'm going to check for solid and dotted lines or dashed lines. And then I'm going to check for my shading. All four of these have to be checked in order to pick an answer choice. Now, one of them we can automatically pick that's wrong is A, because there's no shading here. All right, because there's no shading. Now, first thing I'm going to do is check my y-intercepts. My y-intercepts -2 and +2. So I need to make sure there are y-intercepts at -2 and +2. And it looks like there's not. I'm wondering if Miss Ingram made the wrong graphs. Because one should be right there. One should be right there. One should be right there. And one should be right there. I wonder if she made this at 3 instead of 2. Right there, right there, right there. And this next one should be right there. So what Miss Ingram's going to do, and she is going to get a graph piece of paper and she's going to graph it herself. So if you got one of the questions that wasn't correct, or this answer choice that wasn't correct, I don't blame you at all. All right, I don't blame you at all. So she's about to make this ghetto coordinate grid here. Here we go. Y-intercept, x-intercept, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. Missing one. 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, so let's just go ahead and graph these. Well, why don't we? Graph them what they should be. So I'm going to do the blue one in blue. And I'm going to do this purple one in purple. All right, so down 2, put a dot here. Now my slope is -5/2, meaning I've got to go up 5, 1, 2, 3, 4, 5, and I go over 2, 1, 2. Up 5, or we can go down 5, 1, 2, 3, 4, 5, over 2, 1, 2. All right, and this one is going to be a dotted line, all right, a dotted line because of the sign, all right, because of the sign. So here, dotted line. Now, you have to know what sign this is, all right? You have to know what sign this is. This is either less than or it's greater than, all right, just by looking at it. You have to know this, all right, have to. This is greater than, meaning I'm going to shade everything that is above the line. So not only is it a dotted line, I shade above, because if you think about it, my y values that are getting bigger, that's this way, greater than this way, meaning you shade all of this, all right, all of that. Then our purple line, +2, up 2, and then it's a -2 slope, down 1, 2, over 1, 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 and I keep going. All right, and I can go up 2, over 1, up 2, 1, 2, over 1, up 2, 1, 2, over 1. And this one is a solid line, all right, solid line, because there's a line underneath it. That is greater than or equal to, all right, greater than or equal to, meaning I have a solid line. And if it's greater than or equal to, meaning I shade above. Meaning this is the only thing that they have in common is this section right here. Now, let's see if Miss Ingram just made the answer's wrong. And let's see if there's anything remotely similar to it. And there's not. All right, these are intersecting. All right, these are intersecting. So that is Miss Ingram's bad on that one. Your graph should look something like this. All right, should look something like this. Now, whenever you get your retest for this, and I'll have to make sure that the retest is correct, okay? You need to check your y-intercepts to see if they're right, check their slopes, check the solid and dotted lines, and check the shading, all right? And check the shading. Number 6, all right, number 6, use an elimination. Are they in standard form? Do I have my x's, my y's, and my numbers? And I do. Then is there anything I can eliminate? Not right now, but I could eliminate something really easily. I could eliminate those y's. I just have to make one of these negative. So I'm going to make this one negative. I'm going to multiply it by -1. Negative 7x minus 2y is equal to negative 24. 8x plus 2y is equal to 30, meaning these cancel. 8 minus 7 is, oh my gosh, 1. That's so nice. 30 minus 24 is 6. So my x is equal to 6. Go back to your answer choices. Are any of these 6? Yes, this one is. Now, let's say, for instance, that one wasn't 6. You would have to plug 6 into one of these equations. 7 times 6 plus 2y is equal to 24. 42 plus 2y is equal to 24 minus 42 minus 42. 2y is equal to 42 minus 24. 12 minus 4 is 8. 3 minus 2 is 1. Now, positive or negative? Negative, because my 42 has more. Divide by 2, divide by 2. That's how you get y is equal to -9. All right, this one, ooh, I love these types of questions. We are graphing each one of these points to see if it belongs in this big shaded region, the double shaded region. All right, -3, 4. To the left 3, up 4. Nope. 0, 0, right there. Yes, ma'am, it is. 0, -1, meaning I go down 1. If it's on a dotted line, it is not included. It cannot be on a dotted line. Boop. She can't sit with us. Go over to 2, go down to 3. Ooh, that one's super close, but not there. All right, super close, but not there. So that one's not it. 3, 5, over to 3, up to 5, boop. Now, if she's on a solid line, she can sit with us. She is included. All right, she is included. Then -2, 0, over to -2, 0. Nope, doesn't work. Just remember, if they're on a dotted line, they cannot be there. Cannot be on a dotted line. They can be on a solid. All right, they can be on a solid. And the very last one, the one where most people lost their points. All right, systems of linear equations. Slope intercept, y equals mx plus b. All right, you're going to have 2 slopes and 2 y-intercepts. A slope and a y-intercept. Now, to know what these are, you have to put these in slope-intercept form, meaning you've got to move the 5x, -2y is equal to -5x plus 6, divide by -2, divide this by -2, and that by -2. So y is going to equal 5 over 2x minus 3. So for this blue line, my slope is 5 over 2, my rise over run. Now, my y-intercept's not just 3, it's a point, 0, -3. All right, don't forget about that, 0, -3. Next one, move the 2x to get y by itself. 3y is equal to -2x plus 10. Divide by 3, divide this by 3, and this by 3. So y is equal to -2 over 3x plus 10 over 3. Now, 10 over 3, All right, let's think about that using our calculator. 10 divided by 3 is 3.333, meaning it's in between 3 and 4. All right, in between 3 and 4. Now, that's going to be kind of hard to graph. I'm not going to lie about that. All right, we're going to have to practice that real. Let's start with the easy one. We'll start with blue. All right, -3, the y-intercept. Down 3, put a dot. 5 over 2 is my slope. Go up 5. 1, 2, 3, 4, 5 over 2. Up 5. 1, 2, 3, 4, 5 over 2. Down 5. 1, 2, 3, 4, 5 over 2. 1, 2. Now, because this is an equation, I don't have to worry about solid or dotted lines. I don't even have to worry about shading. I'm only worried to see where these graphs meet. All right, where these graphs meet. All right, now let's graph this hard one. Ooh, Miss Ingram didn't even do this. All right, she's failing on her job. -2/3 is her slope. 10 over 3 or 0, 10 over 3. Now, here's the issue with this is that our slope is -2/3, okay? So let's start at 10/3. So a little bit in between 3 and 4. Down 2, 1, 2 over 3. 1, 2, 3. Down 2, 1, 1, 2 over 3. 1, 2, 3. All right, and look, it crosses at this point right here. All right, you don't really need to draw all these other lines. Now, I know your 8th grade teacher taught you, you only need like a certain amount of points in order for it to be considered a line. All right, even though mine's crooked. So, part C, where did they cross? They crossed at 2, 2. So, what is the solution here? 2, 2 is the solution because that is where the lines intersected. All right, that's where they met, is at those 2 points right there. All right, write an equation for a line that shows the same solution. You can use Hoy and Bucks. Hoy is a horizontal line, y is equal to. Vertical line, x is equal to. Meaning you could use a vertical line that goes through here like this, vertical line, or you could use a horizontal line. Both of them are going to go through 2, or you could literally use any line that goes through 2, 2. You could use y is equal to x. That goes through that right there. Y is equal to x. You could have done, if you want to start at -1 and go up 1, 2, 3 over 2, you could have done y is equal to -1, 3 over 2x is my slope. You could have made any line you wanted to, all right? Horizontal, vertical, diagonal, does not matter, all right? Does not matter. Now, in order for you to retest on this, you need to turn this back in to your teacher, all right? Turn this back into your teacher. Then you and your teacher can talk about retesting, all right? You and your teacher can talk about retesting.